Let's discuss this question next. Question number 13 says, on which of the following intervals is the function f given by fx equals x power 100 plus sin x minus 1 decreasing? On which of these intervals is this function decreasing? And how are we going to deal with this? Let's see, fx is given to be x power 100 plus sin x minus 1. This is what fx looks like. So, the derivative of fx, that is f prime x, what will this look like? This is 100 x power 99 plus derivative of sin x is simply cos x. Okay. Now, if you observe, x and cos are two different types of functions altogether, and actually finding a 0 will be very difficult for this particular case. So, what do we do in this case? We are not supposed to worry too much because we are given certain intervals. Right, and we are supposed to check values within those intervals, values of this f prime x. Yes, let's check for option A, x belongs to 0, 1. In this interval, do you observe that 100 x power 99, this particular quantity will be greater than 0. Yes, this is a positive quantity. This x is positive, therefore x power 99 is positive. Multiplying by 100 will also give me something positive. What about cos x? Now, if you take a look at cos x, the value of cos x in this interval, now this x is in radians actually, this x is in radians. And in terms of radians, when I talk about 1 radian, do you observe that 1 radian is approximately somewhere around 57 degree, right? So, it is still in the first quadrant, right? All of these values lie in the first quadrant, so cos x is also greater than 0. Okay. You can observe that in f prime x, this is positive, implies this is greater than 0. Overall, this is greater than 0 since this is positive and this is positive. Therefore, we can say that f is increasing. Okay, f is increasing. But we were looking at decreasing, we were looking for decreasing. Okay, so A is not the correct answer. Okay, let's talk about option B then. In option B, we have x belongs to pi by 2, comma pi. Okay. So now we are talking about the second quadrant. Okay. And fx is equal to 100 times x power 99 plus cos x. Do you observe that cos x in the second quadrant will lie from 0 to minus 1, or alternatively from minus 1 to 0. This value lies from minus 1 to 0. That's one thing. What about this value over here? Now, if we take a look at 100 times x power 99, what will this value be? X is greater than this pi by 2. And pi by 2, pi is 3.14, pi by 2 is 1.57, which is greater than 1. Right? So, greater than 1 multiplied by 100, this quantity will be anyways greater than 100. Yes or no? Yes. Even if you add minus 1 to this quantity, by the way, this would be very, very huge. This would be even more greater than 100. This will start somewhere around 157 and reach up till 314 by multiplying with this. Oh no, we also have x power 99. Oh, this is even bigger. This is 1.57 raised to power 99, which is a very huge number, and then you'll multiply that by 100. This is very, very big as compared to 100. Even if you subtract 1, you will get a positive quantity, right? So this is always positive. Okay, that implies in this interval the function f is increasing again. The function f is increasing again. Okay, so we were looking for decreasing. No, this is also not the answer. We are left with only option C and D. Now, option C, we have 0 to pi by 2. Let's check. Let's check option C next. X belongs to 0, pi by 2. Okay, now this option is similar to this one because this is the first quadrant. Cos x will be positive and this is also positive, right? This is also positive. So, this gives me f prime x is greater than 0. Okay, again the function is increasing. Okay, the function is not decreasing in any of these intervals, right? The function is increasing in A, B and C. On which of the following intervals the function f given by this is decreasing? None of these options is correct. Therefore, option D is the correct answer for this question, as you can clearly see over here.